Alrighty, we're back here on the workbench, and we've got radio in for our 148 Northern Cal Mud Deck. Let me turn the radio back here just a little bit. We're sitting there listening to some of the skip roll this morning. But anyways, we've got this antenna. We got the antenna actually hooked up to the workbench this afternoon, and we're actually going to be running this here. We'll try to shoot a little bit of skip on it, but kind of want to go through and show what we've done to this. What we've done here, we'll start with some of the components that we went in and replaced. Okay. Now, because of the fact that we went with we replaced the high-low switch. Now, let's see here. Let's grab that first here. Okay, we went ahead and replaced our high-low switch that we had in this system. Okay, this all's been taken out. Well, because of that, our coax was just a little bit too short, so we went ahead and replaced that. That way we can go ahead and make it up to our variable. We did go ahead and rewind the input of our 1-pill driver. This is actually like a 22 gauge. We went up to a 20 gauge so we could change the inductance just a little bit on the amplifier itself. And so that we go ahead and make that into a solid one piece going up to our variable. The other thing that we did was this was on the input of the 4-pill. Okay, well, we went ahead and pulled this out, used a standard silver clad mic or silver dip mica. We needed just a little bit more since we went ahead and added the biasing. So we pulled this out. We needed to go up about 5 more picofarad than what this was for the system to actually tune out properly. So we went ahead and replaced that. Our input, this was in the beginning just a little too low to begin with. So we pulled this out, and we actually put the prospective amount of capacitance on the input so we could go ahead and get it to lay down into resonance. The other thing we did was we got rid of this big old mess. Okay, this was for the delay. It didn't actually have biasing in it, it just had a delay in it. Well, this delay, just big, gaudy, in the way, really wasn't done necessarily wrong, but there was a better way. So we yanked all this out and we replaced it with just a single. So we got this in here. We went ahead and used the original switch that was in the back for the sideband delay. Now this is in full-time B-biasing all the time. One of the other things that we changed out, actually we didn't change it out, we actually just shortened it, which was our combiner resistor here. And the reason why is because the fact that the leads were about that much too long and they were just tacked on each side. So we went ahead and shortened those down, actually wrapped it around both sides like it should have been, resoldered it, and that actually took care of some of the harmonics that we were having on this amp. So that was one of the other small little details that we made a change on. Then we pulled out the original chokes for the Class C and replaced those with these here. And the reason why we did that was for 2 reasons. Number one, the other ones were very large and bulky for the application. Number two, I needed a specific amount of inductance here for our biasing. So that's the reason why we went ahead and changed those and came up with what we needed for the proper inductance going into the input of our 4-pill. Same thing over here for our 1-pill. We did the same thing. There again, now this one, most times there is not a choke here to begin with, which is not actually necessary on a 1-pill. So for the biasing, though, however, it is. So that's been installed. This uses a very unique setup on the biasing, and that's it, guys. I mean, that's all the circuitry that's actually needed. Now, this only works on, this is about as big an amplifier as you can do this with this particular circuitry, and make it stay stable. But it's actually one of the more stable setups. What's nice is because of the HGs, they actually take a little bit less in order to put it into the biasing mode for sideband than what our typical Toshibas do. But anyways, like I said, just wanted to kind of do a rundown here with you guys real quick. The other thing that we did as well on the changeover is right here. These are two 10-gauge wires that was installed into the amplifier. For AM, it would be sufficient. For sideband purposes, not so much. The other side of that too is I really didn't care for the way it was heat shrink down here at the end, so we actually did that in a proper format. Now right now we've just got it clamped together for test purposes here, but like I said, we went ahead and actually covered it and covered the joint like it should have been. Now this has been hydraulically crimped and soldered, so he's going to be able to draw essentially all the current that's capable right through that joint because of that. But anyways, let's move over here and move on to the testing. So when we get back, we'll show you how this thing runs. Alright, now we're back. We're set up here. Let's go ahead and turn our power supply back on. Alright, so what we're doing is we're just using a Cobra 29 we use here on the bench on a daily basis. Right now we've got a variable turned all the way up. Let's find out what we're dead keying here real quick. Turn skip land down. I'm actually going to show you something that a lot of times you don't see. Everybody shows everything on the dummy load, which is great, but the real world is we don't always run on a dummy load. Why? Because we actually want to talk on this. So I'm going to turn this around here for the moment on our 5-watt slug. So we can get in here a little bit closer. Get my lights down so hopefully it's a little bit easier. Okay, now the amplifier's off. We're going to check and see where we're set at currently with a dead key. And it looks like we are at 1 1/10 watts. So we're dead keying. Check the pass-through tune. Hello, audio, audio, which is great. So now we'll move on to the power side of things. So what we can't do here, let's turn the volume back up here on the radio. So 1 watt in gives us a 100-watt dead key on the carrier. Hello, audio, audio, audio. So we've got 700 peak. Hello, audio. About 375 bird. Now this is built with all Type 61 throughout the build, so you're going to see more RMS power than what you are peak because of the design of the amplifier. As far as our reflect, going back from the antenna, hello, audio. You got about a 1.75 watt reflect, which is acceptable considering the output power. Input tune, hello, audio. About a watt reflect, Now the reason why that all sounds high is because we are using, real world numbers as far as throughout the whole bench on this. So see if we can get in here real quick, and we'll see if we can make a contact. How about it, Connecticut? How about that, Connecticut? 006, South Central Indiana, the Rainmaker, waving that hand. Never know, guys. How about it, DX Land? DX Land, 006, 006, South Central Indiana, we're waving that hand. Okay, well, it doesn't look like conditions are going to be in our favor there today. That was early this morning when I was playing around with this before we finished up our video. But we'll get you up here a little closer. So we'll get this off there. Okay, so we got a 1,000 watt slug in PEP, 500 watt slug in average. Hello, how about it, DX Land? DX Land, 006, the Rainmaker. We're waving that hand. How about it, DX Land? DX Land, 006, South Central Indiana. We're going to wave that hand. Hello, my radio. I hear somebody out there in the distance coming back to me there. I hear somebody out there in the distance. Be 006, the Rainmaker, waving that hand. I hear him, but it's real faint. How about that big signal up there in Texas? If you got a copy in a 006, 006, South Central Indiana, we're trying. Yeah, I guess it's just not going to be our time to shine here. But anyways, guys, like I said, we wanted to go through here and give you a little preview of it. So, guys, we appreciate your time. Like I said, hopefully you find this a little bit, turn them guys down. Hopefully you found this a little bit, educational and enjoyed the video. Like I said, just kind of want to show some real world numbers. We're trying to do things a little differently this year. Like I said, we're trying to increase our amount of YouTube videos. We will be doing some other interesting videos too, as far as on coaxial lengths, calibrations, and what have you, because it's become more and more apparent that with the new HG transistors that we're dealing with, such as the ones in this, that coax length is actually very, very critical, guys, in order to have everything in a harmonious outcome. So everybody, I appreciate it. Like I said, I hope you enjoyed this video. So we're going to go on to the next stuff. It is still early here for me, and we're still working on getting everything taken care of. So everyone, we appreciate it. If you would, please hit the like and subscribe button, and we'll see what we can do about putting more videos up for you. Have a great day, guys.